Okay, fine, let's start. So yesterday we have seen an example of hypothesis testing. Okay, so and also I think we have started day before yesterday to understand what is hypothesis testing. Okay, now let's try to discuss. Okay, let's try to discuss this type 1 and type 2 error once again. Okay, see guys. Yeah, see, to start with, first of all, we will define something called as null hypothesis, and from this we can generate alternate hypothesis as per our requirement. Okay, so now there are two things, one is null and second thing is alternate hypothesis, and we will do some test. Agree? So what was the process? So we will follow this process. Okay, and if our value is falling in the rejection region or the critical region, we will reject the null hypothesis. Okay, if it is not falling, we will accept it. Agree? In our first example, it is falling in the critical region, so we are rejecting the null hypothesis. In the second example, it is not falling, it is falling inside this non-rejection region. Okay, that's why we are not able to reject, but we are accepting the null hypothesis. Okay, so here, but the error might happen when whatever the null hypothesis we are saying, right? So okay, so as I said, mostly we will take the null hypothesis and we will work on this and we will try to either accept or reject it. Okay, so that automatically we are deciding on the alternate hypothesis also. How? If you are accepting null hypothesis, that means we are rejecting it. If you are rejecting null hypothesis, that means we are accepting this. Agree? So indirectly this will be selected. So that's why we don't specifically talk about alternate hypothesis most of the time. Okay, so mostly we talk on the null hypothesis. Okay, so now let's say you have, this is a null hypothesis and you have accepted a null hypothesis, but later you came to know that this is a false null hypothesis. Okay, later you came to know this is a false null hypothesis. Okay, or you have rejected a null hypothesis, but it turned out to be that's a true null hypothesis. Okay, so ideally what should happen, guys? If it is a true null hypothesis, you should accept. Agree? Ideally, if there is null hypothesis, if it is true, what you should do? That you should accept. If it is false, what you should do? That you should reject. Agree? This is ideal case in any scenario. Okay? That means what? If a person has committed crime, okay, the judge should give punishment to him. Or if the person is innocent, he should be evicted. He should be released without any charges. Agree? But if it is the other way around, then that is an error. Getting? Similarly, if null hypothesis is true, instead of accepting, if you're rejecting, this is an error. Okay, this will be an error. Similarly, if a null hypothesis is a false, okay, but you have accepted it due to some reason, that is also an error. Okay, is this logic clear, guys?
I mean, these two we have seen in the above two examples, right, Santosh? In the first example, the false.
No. Where we have seen, man? Here, see, here null hypothesis is 50, alternate is something. You have rejected the null hypothesis. Okay, but sorry, that does not mean null hypothesis is false. Don't get confused. Here you have formulated the null hypothesis, you have formulated alternate hypothesis. Here, actually, whatever this guy is saying, right? The average productivity is 50 units per day of the population. You consider that. See, Karthik, the company is saying the average productivity is 50, and you have considered that as a null hypothesis. Agree?
Agree.
And alternate you have formulated because you want to check the productivity increase. You have considered
Yes.
this. Okay.
Yes.
After that, now in this scenario, null is true. Okay, null is true. Okay, and what you have done? See, true in the sense. Okay, I get your point. See, true in the sense these are two statements. Whether this is true or not, we don't know. Okay, that's the
Okay.
point. That's the point.
Okay.
Okay,
Okay. Okay.
what is the point here? Oh, see, that's a good point actually you raised. See, we are creating an null hypothesis in this way. We are creating alternate hypothesis in this way. We don't know which one of this is true in this scenario, because if we know what is true, why we'll do testing? Why we should do this hypothesis testing? Everything, no need, right? We can directly say, hey, uh, the uh, the
Correct.
the
Correct.
training has
Correct.
already increased the productivity. That is a statement. Final. Why?
Yes.
See, these both of these are just our assumptions, guys. These are not facts. When you will get the fact, once you do this testing and once you perform this every critical region, everything, and from that you can decide whether you want to accept this or you want to accept this. Okay, before that you are just assuming these two. Hey, this is null hypothesis, this is alternate hypothesis. You don't know which one is true, which one is false. Getting my point?
Okay. So in this case, we don't know.
You don't
So
know. You don't know because company is saying, okay, see, here company is also, what does the company is saying? Company is not saying anything. Company is just asking us, hey, I want to know if the new training has significantly increased the productivity. He's just asking, I have given some training to my students, okay, and I want to see if that training has increased the productivity or not. That's all. For that what we are saying, see, this mu equal to 50 is what this is not. I'm not saying mu equal to 50 is the mu equal to 50. I'm saying after the training, okay, after the training also, the mu equal to 50, the mean is 50 is what is what this null hypothesis is saying. What does null hypothesis saying? Here he's saying even after the training also the mean is 50. That means there is no effect on any single employee. That's what this guy is saying. This is not, this 50 is not from the population 50. What does hypothesis testing will say? See guys, see, let's sorry, let's take step back a moment and we'll try to understand it again. See, these are the details, guys. See, whatever you get, okay, from the data, population, all these are details. Put that aside. First of all, the company is asking us, hey, please do me this test and let me know if the training has increased the productivity or not. Clear? That is a requirement from the company. Clear?
okay.
Now, we don't know. I don't know whether the training actually helped the employees or not. I don't know. Okay. So for that, I need to create two hypotheses. One is null, one is alternate. Okay. What null will say, hey, the training did not have any effect. Actually, the productivity of the employees before the training and after the training is same. That's what this guy is saying. As I said in the first class, null hypothesis will always say nothing interesting is happening. No relationship is existing. There is no dependency. Okay. It will always try to create hypothesis in that way. Why? So that we can create alternate hypothesis contradicting to that. Okay. And then we can start proving null or alternate, false or sorry, we can accept or reject one of these. First of all, the way we create null and alternate hypothesis is in such a way that null will always say, if the question is like, if the productivity is increased, he will say, hey, no, it is not increased. If the question is, if there is any relationship between the two variables, null will be created such that it will be saying, hey, there is no relationship. Alternate will say there is relationship. These two are statements as of now, just statements. You will start the testing after the statements and you will come up with some evidence so that whether you can reject the null or accept the null, or whether you can accept the alternate or reject the alternate. Okay, these are just statements. So here, what does the null? How did I take the null? I took the null as mu equal 50. That means what? After the training also. So these both are for the after the training. See, after the training also, the mu equal to 50 only. That means what? Before the training, anyhow, it's 50. but after the training is also 50, means there is no increase in the productivity. Agree?
Yes.
Okay, but alternate is saying, hey, mu is greater than 50. That means there is some productivity. So these two are just statements as of now. Let's assume I did not start this test anything. Initially from this question, I have created two hypotheses where null is saying, hey, it is equal to 50 only, even after the training. Alternate is saying, no, it is greater than 50. These two are statements. Now, after the training, after this testing, whatever the statistic, whatever I do, and from this rejection region, okay, if at all I get some evidence, that means what? If my Z statistic is falling in this rejection region, then I will come here and say, hey, I have sufficient evidence from this calculation, and because my Z statistic is falling in the rejection region, I am going to reject this guy. So earlier these two are just assumptions, hypotheses. Okay, but after the test I got evidence. Now this becomes statements. Now I will say, hey, I'm rejecting you because I'm accepting you. Yes, the productivity is actually increased. But for example, this particular value is very low. That means if at all it is falling in the non-rejection region, then what I will do, I'll come here and I'll say, hey, I don't have any evidence. Whatever the null hypothesis is saying, I should accept it. Okay, I cannot reject it. So I will say, hey, yeah, whatever you're saying is true. I'll accept you and I will reject you.
Okay. So from this, can you please go to the box, Santosh, that box?
Okay. Yeah. So, right. So I'm coming. See, give me one more second. So we have done this. Okay. Whatever we have done, let's say we have, in this scenario, what we are doing, we have rejected the null hypothesis. Okay. In this scenario, what we have done from this test statistic, initially we have created null and alternate. Okay. And then you have some evidence 3.28 because it is falling over here. You came here and said, hey, I'm going to reject you guys. Okay, I'm going to accept this. Okay, I'm going to accept this. Okay, that you have done. Okay, but now when you're accepting null alternate hypothesis, what does that mean? Tell me, what does that mean?
Null hypothesis is rejected.
Yeah, correct. But according to this question, what does that mean? From this example, I'm rejecting the null hypothesis because my test statistic is falling in the rejection region. So I'm coming here and saying, hey, I'm going to reject the null hypothesis and I'm going to accept the alternate hypothesis. So when I'm doing that, what does that mean?
Increasing the productivity is the correct.
Yeah, correct. So increasing this is a correct. Okay. So I've accepted. So I have done what? I have rejected the null hypothesis and accepted this. Fine. That is as per your assumptions, as per your test, as per your calculation, as per your values, everything that is perfectly correct. Okay. You are happy now that you have done what? You have rejected the null hypothesis. Fine. But my question is, this table comes into picture. This table comes into picture when, based upon what you have done these calculations, based upon the sample. Okay, based upon the sample of 30 and sample mean of 53, these values the company has given, right? Hey, take this sample and take this productivity, that the average productivity of the sample is 53. Based upon these calculations only, you have done this statistic and you got this value. Okay, but what does the company actually, but based upon this, based upon the test, whatever you are doing, okay, what you are actually saying, you are not saying about the sample, you are saying about the population. Are you able to understand? Company is not interested in sample. Company is interested in the population. Lost. See,
okay, got it.
see,
Okay.
yeah. Company is saying initially my whole population, I don't know how much is population, let's say 1,000 employees, their productivity is 50. Okay, then I have applied some training. Okay, now from this 1,000, I'm giving you sample of 30 because I cannot waste time of every 1,000 employees. So I'm giving 30, and this 30 sample is 53. Sample mean is 53. Okay, do some testing and let me know. Okay, if the productivity is increased. Now, if the productivity is increased means the company is not concerned about just this 30. He is concerned about the whole 1,000 people, right?
Correct.
Because that's what, see, in our complete statistics journey, what we were doing, Because we cannot have the complete access to the population, we will take a sample, we will do our test on the sample, and based upon the samples scenario, we will try to predict the value for the population. Okay, even the whole center limit theorem also, what does it say? If you take sufficiently enough number of samples, whatever the mean you are getting, okay, that will be same as a population mean. Okay, see guys, it's fine, it's a new topic, so let's make it very clear. See, even in this scenario also, yeah, in this scenario also, there is a population. Okay, from that, in the central limit theorem, I'm going back to central limit theorem. In this there is a population, you are taking multiple samples. Okay, and for the samples you are taking mean. Okay, and this sampling mean, whatever you take, that will be almost equal to the population. Okay, that's what we have studied. Do you agree, guys? This one?
Yes, Santosh.
Okay, here, why we are saying, hey, the mean of the sampling mean is almost equal to population? Because we don't know the population mean. Our whole goal is actually to have the values of the, to know the values of the population. Because see, if at all you already know the population mean, okay, because you already know the population mean, then there is no need of doing all this. Okay, because you do, because most of the time you cannot get the whole population data. That's why you will take some samples, 30 each or 40 each. You will take and you can calculate the means of these samples. And when you do the sampling mean of all these means, whatever the value you are going to get, that will almost be equal to the population mean. So even though even though you do not have the access to all this, let's say 10 crore population, which is impossible, but you can do the small steps, and whatever the mean you are going to get, that will be almost equal to the true population, the population mean. Okay, so indirectly you are getting the population mean. But in the first step itself, if you have the access and if you have the patience to collect the data of the 10 crores people and calculate the mean, then there is no need of this. Because when you already have the population details, then why the hell I will care about the sample? Because if I have the whole population, my data will be more accurate, I will have more data, my models will be perfect, everything will be happy. But that is not possible practically. That is the same issue we are facing throughout our statistics journey. Because population parameters or population values will mostly unknown. That's why we are coming up with these techniques, so that we can take some samples and work on that samples and create some theorems and finally try to estimate the parameters of the population. So that when you see, when this mean of the sample mean is almost equal to the population mean, that means indirectly we can feel that working on the samples is almost equal to working on the population. Because ultimately, what does a data, what is a data is just we don't use the complete data points, we will use some point estimates of that data point. That means whether a mean, whether a standard deviation, whether variance, we just work on these values. We don't use the whole data values actually. You getting? If a data is having 1000 values, we don't use every one value from that. We will take an average value of that, or we will take a standard deviation, or we will take a variance from that, and we will do some calculations. Agree? Similarly here also, when we are finding this and when we are having confidence that, hey, whatever we are doing here, the sample mean is almost equal to population, that means indirectly, okay, if you work on these samples, it is almost equal, if not 100%, at least almost equal to working on the actual population itself, because same parameters you are working. Are you getting this?
Yes, Santosh.
No, tell me honestly. Or is this any confusions? We'll like go again. That's completely fine. Megan and Sirisha, this point, did we get it? We'll again go back to hypothesis testing, but this we have revisited the central limit theorem. Is the point clear over here? What I was trying to convey?
Yes, sir. But how do we know that population and the result we get by testing how it is
No,
correct?
here or in the hypothesis testing?
Hypothesis testing.
Okay, yeah, we'll go there. So here, so this concept is clear, right? So now if I go here, yeah. So Meghna, come again. What was your question?
అంటే ఇప్పుడు మనం టెస్టింగ్ చేస్తాం కదా సార్, టెస్టింగ్ చేసినాక మనకు వచ్చిన వాల్యూ కరెక్టా కాదా అనేది, అంటే ఎర్రర్ ఉందా లేదా అనేది మనకి ఎట్లా
కరెక్ట్. దట్స్ ఎ గుడ్ క్వశ్చన్. యా. సో కరెక్ట్. ఇప్పుడు వాళ్ళు ఇచ్చిన వాల్యూస్ ప్రకారము మనం ఇవి తీసుకున్నాము. ఓకే, మనం ఏం క్రియేట్ చేయలేదు. వాళ్ళు ఇచ్చిన వాల్యూస్ ప్రకారం మనం ఇవి తీసుకున్నాము. ఓకే, దాని తర్వాత ఇది క్యాలిక్యులేట్ చేసినాము. ఇచ్చిన వాల్యూస్ ప్రకారం ఇది రిజెక్షన్ రీజన్ లో ఉంది, అందుకే రిజెక్ట్ చేసినాం. దట్ ఈస్ 100% పర్ఫెక్ట్. ఓకే, బట్ నేనేమంటున్నా అంటే నువ్వు అడిగిన పర్ఫెక్ట్ క్వశ్చన్. సో మనకి ఎలా తెలుస్తుంది అంటే ఇఫ్ ఎట్ ఆల్ డ్యూ ఆఫ్టర్ సమ్ టైమ్, ఓకే, ఇఫ్ అది మన మిస్టేక్ అనట్లే, ఎర్రర్ అనేది మన మిస్టేక్ కాదు. ఇఫ్ ద కంపెనీ అగైన్ బై సమ్ మీన్స్ దే హ్యావ్ అగైన్ calculated this 1000 people's employee. Okay, this 1000 people's samples, sorry, after training మనకి యాక్చువల్గా టెస్ట్ చేయడానికి 30 samples ఇచ్చారు కదా. ఓకే, ఆ 30 samples తోని మనం ఇది క్యాలిక్యులేట్ చేసాము. మనం ఆల్టర్నేట్ హైపోథెసిస్ అనేది యాక్సెప్ట్ చేస్తున్నాం. అప్పుడు మనకి ఏమొచ్చింది, ఏంటి సిగ్నిఫికెంట్లీ ఇంక్రీజ్ అయింది ప్రొడక్టివిటీ అనేది మనకు తెలిసింది. ఓకే, సో మనము యాక్సెప్ట్ చేసాం. ఈ నల్ అనేది మనం రిజెక్ట్ చేసాము, ఆల్టర్నేట్ అనేది యాక్సెప్ట్ చేసాం. ఓకే, అదేది ఓవరాల్ పాపులేషన్కి చెప్తుంది ఇది. ఓకే, ఈ శాంపుల్ తోని వీఆర్ ట్రైంగ్ టు ప్రొజెక్ట్ ద వాల్యూస్ ఫర్ ద పాపులేషన్. ఓకే, ఎందుకంటే జస్ట్ శాంపుల్ మీద మనము వర్క్ చేస్తే వచ్చే వాల్యూస్. ఓకే, సో యూ కెన్ యూజ్ ఇట్ ఫర్ ద పాపులేషన్ జస్ట్ లైక్ ఇన్ ద సెంట్రల్ లిమిట్ థీరం. ఓకే, ఓకే, ఆర్ వి గుడ్ టిల్ దిస్ పాయింట్?
ఎస్ సార్.
ఓకే, దీని తర్వాత మనం ఏం చెప్తున్నామంటే ఫ్రమ్ దిస్ శాంపుల్ మేము చేసిన టెస్ట్ ప్రకారము ప్రొడక్టివిటీ యాక్చువల్లీ ఇంక్రీజ్. కావాలంటే మీరు చెక్ చేసుకోండి, ప్రతి ఒక్క పర్సన్ది ప్రొడక్టివిటీ అనేది పెరిగే ఉంటుంది అని మనం స్టేట్మెంట్ ఇస్తున్నాం. వాళ్ళు ఓకే అవునా అని చెప్పి ఇఫ్ ఎట్ ఆల్ వాళ్ళు టెస్ట్ చేశారు అనుకోండి, దే టుక్ సమ్ టైమ్, 1 day హాలిడే తీసుకొని దే టెస్టెడ్ ద ప్రొడక్టివిటీ ఆఫ్ ఆల్ 1000 people. ఓకే, సో 1000 యాక్చువల్గా ప్రొడక్టివిటీ అనేది సేమ్ ఉంది. ఓకే, ఒకవేళ ఓన్లీ పర్టికులర్ శాంపుల్కే అలా పెరిగింది, తెలియదు, వాళ్ళ ఒక ప్రాజెక్ట్కి సంబంధించిన వాళ్ళు ఉండొచ్చు, లేకుంటే వాళ్ళు ఫ్రమ్ ఐఐటీస్ అయి ఉండొచ్చు. ఓకే, వాళ్ళు హైలీ మోర్ ఎక్స్పీరియన్స్ సీనియర్స్ ఉండొచ్చు. ఓకే, అలాంటి వాళ్ళకి ట్రైనింగ్ ఇస్తే ఆబ్వియస్గా ప్రొడక్టివిటీ ఇంక్రీజ్ అవుతుంది కదా. ఆర్ యు గెటింగ్ మై పాయింట్?
ఎస్.
ఓకే, సో మనకి ఆ పర్టికులర్ శాంపుల్ తోని మోస్ట్ ఆఫ్ ద టైమ్ ఇట్ విల్ వర్క్. ఓకే, బట్ ఇన్ కేస్ సమ్ టైమ్స్ వాట్ మైట్ హ్యాపన్ ఈస్ ఈ శాంపుల్ బట్టి మనం వీఆర్ ప్రొడక్టింగ్ ద వాల్యూస్ ఆఫ్ ద పాపులేషన్, దట్స్ ఫైన్. బట్ ఇన్ కేస్ ఇఫ్ అట్ ఆల్ ఇఫ్ యూ ఆర్ ఏబుల్ టు గెట్ ద పాపులేషన్ వాల్యూ, వాళ్ళ కంపెనీ ఒకవేళ చెక్ చేసి హే మీరు చెప్పిన దాని ప్రకారం చెక్ చేసాము, బట్ 1000 మెంబర్స్కి మేము చెక్ చేస్తే ప్రొడక్టివిటీ అనేది అంతేం పెరగలేదు, ఓవరాల్గా అది 50 ఉంది అన్నారు అనుకోండి. అప్పుడు ఓకే, అప్పుడు what is our null hypothesis saying? If null hypothesis is saying mean is almost equal to 50, okay, then it is true. Okay, in this scenario, if the company is also saying even after the training, okay, even after the training 50 ఉంది అని అంటే our null కూడా అదే చెప్తుంది కాబట్టి it is true, there is no error. Okay, there is no error. Okay, no, did I say it wrong? Okay, let me come again. So initially we have considered the null is 50 and alternate is greater than 50. So from our test what we got 3.28 and we have rejected the null hypothesis. Okay, null hypothesis saying what? Mu equal to 50 అనేది they are stating. Okay, yeah. So if at all if this is true, actually ఇది we are rejecting the null hypothesis, right? If we are rejecting the true null hypothesis, okay, we are rejecting the true null hypothesis. Yeah, correct. So yeah, my example was correct, right? Yeah, so even after testing, okay, 1000 people కి కంపెనీ వాళ్ళు టెస్ట్ చేసి if they say యాక్చువల్గా అది 50 ఉంది అని అన్నారు అనుకోండి. ఓకే, యా, ద సేమ్ ఎగ్జాంపుల్, వాళ్ళు మన మాట నమ్మి if they want to test our statistics, okay, వాళ్ళు they took some time and ఈ 1000 people ప్రొడక్టివిటీ టెస్ట్ చేశారు, అది 50 వచ్చింది. గెటింగ్ గైస్?
ఓకే,
ఓకే, అప్పుడు మనం ఏం చేసినట్టు, యాక్చువల్గా మనం ఏం చెప్పాము, హే మా టెస్ట్ ప్రకారము మీరు ఇది క్యాన్సిల్ చేసుకోండి, ఆల్టర్నేట్ ని యాక్సెప్ట్ చేసుకోండి, ఎందుకంటే ప్రొడక్టివిటీ అనేది ఇంక్రీజ్ అయిందని మనం స్టేట్మెంట్ ఇచ్చాం. క్లియర్ టిల్ దిస్ పాయింట్? మనం స్టేట్మెంట్ ఇచ్చాం.
ఎస్.
ఓకే, దాన్ని బట్టి వాళ్ళు ఏం చెప్పారు, అవునా సరే మేము కూడా టెస్ట్ చేస్తామని చెప్పి వాళ్ళు 1000 మెంబర్స్ కి, శాంపుల్ కాదు మేము చెక్ చేసామని 1000 మెంబర్స్ కి వాళ్ళు టెస్ట్ చేస్తారు. టెస్ట్ చేస్తే ఏమొచ్చింది, 50 వచ్చింది.
దట్ ఈస్ ట్రూ యాక్చువల్లీ.
దట్ ఈస్ ట్రూ, ఎందుకంటే నువ్వు
And we are
పాపులేషన్ కి
rejected.
టెస్ట్ చేసినప్పుడు ఇంకా అది ట్రూ, దానికి నుంచి ఏముండదు.
Yes, yes.
శాంపుల్
So
మీద నీకు రాంగ్ అయ్యే ఛాన్స్ ఉంటుంది, కానీ పాపులేషన్ ఓవరాల్ మీద టెస్ట్ చేసినప్పుడు ఇంకా అదే, దట్ ఈస్ ద అల్టిమేట్ థింగ్. ఓకే, సో అప్పుడు అప్పుడు ఏమైనట్టు, సి మేఘన్, ఆర్ యు ఆన్ ట్రాక్?
Yes, sir.
Okay. Sirisha, you're also getting right because this is a small logic here. That's it. Yeah. సో ఇక్కడ ఏమవుతుందంటే మన టెస్ట్ ని బట్టి వాళ్ళు ఒకవేళ టెస్ట్ చేస్తే ఓవరాల్ గా నీకు 50 వచ్చింది అనుకో, వాళ్ళు ఏమంటారంటే హే యూ సెట్ టు యాక్సెప్ట్ ద ఆల్టర్నేట్ హైపోథెసిస్, యూ సెట్ ద ప్రొడక్టివిటీ ఇంక్రీజ్, బట్ మేము ఓవరాల్ గా టెస్ట్ చేస్తే 50 ఉంది. నౌ వాట్ డస్ దట్ మీన్? అవర్ నల్ ఏం చెప్పింది, యాక్చువల్ గా హే ద ప్రొడక్టివిటీ అనేది 50 ఉంటది, ఏం పెరగదు అనేది చెప్పింది. ఓకే,
కరెక్ట్.
ఇనిషియల్ నల్ అదే చెప్పింది కదా. నల్ ఏం చెప్పింది, ప్రొడక్టివిటీ అనేది 50 ఉంటది ఈవెన్ ఆఫ్టర్ ద ట్రైనింగ్, ప్రొడక్టివిటీ ఏం ఇంక్రీజ్ కాలేదని చెప్పింది. ఓకే, అండ్ దట్ ఈస్ ట్రూ. హౌ దట్ ఈస్ ట్రూ? దట్ ఈస్ నాట్ ట్రూ ఫ్రమ్ అవర్ టెస్టింగ్, దట్ ఈస్ ట్రూ ఫ్రమ్ ద కంపెనీ ఇట్ సెల్ఫ్.
Yes.
ఓకే, కంపెనీ ఆల్సో, నౌ కంపెనీ ఈస్ గివింగ్ అస్ హే ఇట్ ఈస్ యాక్చువల్లీ ట్రూ. కానీ మన టెస్ట్ ప్రకారం ఏం చేసాము, మన టెస్ట్ ప్రకారం డ్యూ టు సమ్ ఇక్కడ క్యాలిక్యులేషన్ మిస్టేక్ కావచ్చు ఫర్ ఎగ్జాంపుల్, ఆర్ మనకి ఇచ్చిన శాంపుల్ వల్ల కావచ్చు, మనము హే రిజెక్షన్ రీజన్ లో ఉంది మేము రిజెక్ట్ చేస్తామని చెప్పి దీన్ని రిజెక్ట్ చేసేసి దీన్ని యాక్సెప్ట్ చేసాం. సో ఇప్పుడు మనం ఏం చేసాము, ఇప్పుడు నల్ హైపోథెసిస్ ట్రూ ఆర్ ఫాల్సా? యాక్చువల్ గా యాజ్ పర్ ద కంపెనీ
ట్రూని రిజెక్ట్ చేస్తాం బేస్డ్ ఆన్ టెస్ట్.
సో నల్ హైపోథెసిస్ అనేది ట్రూ, దాన్ని మనం ఏం చేసాము, రిజెక్ట్ చేసాం. అది ఎర్రరే కదా.
అంటే బేస్డ్ ఆన్ అజంప్షన్ ఇట్స్ ఎర్రర్.
కరెక్ట్. సి ఈ టెస్టింగ్ చేసినప్పుడు వి విల్ డూ అవుట్ ఇన్ ద శాంపుల్. ఈ ఎర్రర్ అనేది ఎప్పుడు వస్తుంది అంటే వెన్ యూ నో ద ఓవరాల్ పిక్చర్. ఈ ఎర్రర్ మనం చేయము, ఓకే, కానీ మన వల్ల జరుగుతుంది. ఎట్లా అని అంటే వి విల్ టేక్ సమ్ శాంపుల్స్ ఆర్ అండ్ విల్ డూ అవర్ టెస్టింగ్, బట్ లేటర్ ఫ్రమ్ ఫ్యాక్ట్, ఓకే, ఫ్రమ్ ఫ్యాక్ట్ ఇఫ్ యూ నో యాక్చువల్లీ ద ట్రూ పాపులేషన్ పారామీటర్ ఇస్ లైక్ దిస్. ఓకే, మనకి యాక్చువల్గా ఎక్స్టర్నల్ డేటా అనేది రావాలి, ఆల్రెడీ పాపులేషన్ మీద కానీ లేకుంటే ఆల్రెడీ సమ్ ఎక్స్పర్ట్స్ కానీ యాక్చువల్గా వాల్యూ అనేది పెరిగింది లేకుంటే ఎఫెక్ట్ అనేది చూపిస్తుంది, రిలేషన్షిప్ అనేది ఉంది అనేది యాక్చువల్గా అక్కడ ఉంది అనుకోండి, అది మనకు తెలియదు, టెస్టింగ్ చేసినప్పుడు మనకు తెలియదు. ఓకే, ఆఫ్టర్ ద టెస్టింగ్ మనకి తెలిసింది అనుకో యాక్చువల్లీ ద వాల్యూ ఈజ్ మోర్ ఆర్ లెస్ అనేది, అప్పుడు దాంతో కంపేర్ చేస్తే మన నల్ హైపోథెసిస్ అనేది ట్రూ ఫాల్స్ ఉంటుంది. మనం దాన్ని రిజెక్ట్ చేస్తే ఒక ఎర్రర్ అవుతుంది, ఫాల్స్ దాన్ని యాక్సెప్ట్ చేస్తే ఒక ఎర్రర్ అవుతుంది.
Okay. So as per the problem statement, we are correct. But later in the company point of view, we will get to know it's an error or not.
Yes.
Okay.
Is that your question, Meghana?
Yes, sir.
ఇదేనా?
It is.
ఓకే, సో ఇప్పుడు క్లియర్ ఉంది కదా. మనకి ఎప్పుడు ఎర్రర్ అవుతుంది అని అంటే మనకి ఇచ్చిన వాల్యూస్ తోని దట్స్ క్లియర్, మనం క్యాలిక్యులేట్ చేసాము యాజ్ పర్ అవర్ స్టాటిస్టిక్ ఎవ్రీథింగ్ దట్ ఇస్ పర్ఫెక్ట్లీ ఆల్ రైట్. ఓకే, బట్ ఇప్పుడు ఇక్కడ అంటే మనకి తెలిసింది, బట్ సమ్ టైమ్స్ ఏమవుతుంది అంటే ఫర్ ఎగ్జాంపుల్ మనము సింపుల్ గా ఒక 100 డేటా పాయింట్స్ తీసుకోవచ్చు. 100 డేటా పాయింట్స్ తీసుకొని దాని మీన్ అనేది క్యాలిక్యులేట్ చేయొచ్చు. ఓకే, మీన్ అనేది క్యాలిక్యులేట్ చేసి సైడ్కి పెట్టుకోవచ్చు. ఓకే, బట్ ఇది మనకి తెలియదు అనుకుని అజ్యూమ్ చేసుకుందాం. ఓకే, ఈ 100 డేటా పాయింట్స్ లో జస్ట్ మనం ఒక 30 డేటా పాయింట్స్ తీసుకుందాం. ఓకే, దీని మీన్ క్యాలిక్యులేట్ చేద్దాం. దీని మీన్ క్యాలిక్యులేట్ చేసి వి విల్ సే ఇట్ ఈస్ సమ్, వి విల్ జస్ట్ సే ఇట్ ఈస్ గ్రేటర్ దెన్ 30 ఆర్ లెస్ దెన్ 30 అని నల్ హైపోథెసిస్ అనేది ఫార్ములేట్ చేద్దాం. ఓకే, బట్ after that you can check with the true population value and see whether this is matching with this or not. Did you get? No.
Yeah, got it.
Okay,
Got it.
or you can see, or you can actually in the which example I can take, example is one, and what example we can take. let me just think of mobile example. Using mobile, getting up in the morning. Okay, fine. See, until normal, just practically speaking. So if you just make a hypothesis, I will say, hey, getting up in the morning. Oh, or we can do this particular example. Okay, usually we have schools, right? So sometimes what they do is schools tuitions they will make mandatory. Did this happen to you guys? It happened to me. Like when I was studying in the 7th class, they told, hey, everybody should join school tuition, mandatory for some years. Did anybody also face this?
Yes, sir.
Yes, good. So మనం ఒక hypothesis ఏం చేయొచ్చు అంటే school tuitions, the people who are studying in the school tuitions are getting good marks when compared to the outside tuitions. Another hypothesis just, okay? So అందులో ఏమవుతుంది? See, so so okay, overall population లో, ఓకే, సో లెట్స్ సే 100 మెంబర్స్ స్టూడెంట్స్ ఉంటే దాంట్లో 40 మెంబర్స్ స్టూడెంట్స్ స్కూల్ ట్యూషన్లో చదువుతారు. ఓకే, అవుట్ సైడ్ 60% అనేది వెళ్తున్నారు. సో ఐ విల్ మేక్ అజంప్షన్, హైపోథెసిస్, స్కూల్ ట్యూషన్స్ ఆర్ ద బెస్ట్ ట్యూషన్స్. ఓకే, సో స్కూల్ ఏమంటుంది, ఓకే జస్ట్ టెస్ట్ ఇట్ అని చెప్పి, ఫర్ ఎగ్జాంపుల్ నాకు to have a normal distribution, I should have more greater than 40 number of sample sets. So okay, ఈ 40లో ఈ శాంపుల్ ఇస్తుంది నాకు. ఓకే, సో లెట్స్ సే జస్ట్ ఫర్ ద నార్మల్ డిస్ట్రిబ్యూషన్ నంబర్స్ ఓవరాల్ 500 ఉన్నారు అనుకోండి. ఓకే, దాంట్లో 100 మెంబర్స్ అనేది వాళ్ళు స్కూల్ ట్యూషన్కి వస్తున్నారు. ఓకే, జస్ట్ టు హ్యావ్ నార్మల్ డిస్ట్రిబ్యూషన్ పారామీటర్స్. ఓకే, 100 మెంబర్స్ స్కూల్ ట్యూషన్కి వస్తున్నారు. దాంట్లో నాకు ఒక శాంపుల్ 40 మెంబర్స్ నాకు స్కూల్ మేనేజ్మెంట్ ఇచ్చింది టెస్ట్ ఇట్ అని చెప్పి. ఓకే, ఈ 40 మెంబర్స్ నేను టెస్ట్ చేస్తే ఓకే, వాళ్ళు ప్రీవియస్ కన్నా ఇప్పుడు బెటర్గా చదువుతున్నారు అని నాకు తెలిసింది అనుకో. సో వాట్ ఐ విల్ సే హే, నల్ ఏం చెప్తుంది? నల్ విల్ సే, హే, దెర్ ఇస్ నో ఎఫెక్ట్ బిఫోర్ అండ్ ఆఫ్టర్ ద ట్యూషన్, ఇట్స్ పర్ఫెక్ట్, దేర్ వాట్ టు సే మెరిట్ ఈస్ నాట్ ఇంక్రీస్డ్, నల్ చెప్తుంది. ఓకే, ఆల్టర్నేట్ వాట్ ఇట్ విల్ సే, హే, నో యాక్చువల్లీ స్కూల్ ట్యూషన్ ఇస్ హ్యావింగ్ ఎఫెక్ట్ అనేసి ఆల్టర్నేట్ చెప్తుంది. ఐ విల్ డూ సమ్ టెస్టింగ్ అండ్ ఐ విల్ సీ, హే, ఆల్టర్నేట్ వాట్ యూఆర్ సేయింగ్ దట్ ఈస్ ట్రూ అనేది నేను యాక్సెప్ట్ చేస్తాను, నల్ని రిజెక్ట్ చేస్తాను. ఓకే, నల్ని రిజెక్ట్ చేస్తాం. క్లియర్? ఆర్ వి గుడ్ టిల్ దిస్ పాయింట్?
Yes, sir.
ఓకే, సో బేస్డ్ అపాన్ ది శాంపుల్ 40 మెంబర్స్ నేను టెస్ట్ చేస్తే నాకు బెటర్ అనిపించింది. కానీ నాకు 40 తెలుసు, కానీ స్కూల్కి ఓవరాల్ తెలుసు కదా. స్కూల్ వాళ్ళు ఏం చేస్తారు, ఈ ఓవరాల్ 100 పాపులేషన్ చెక్ చేసి వాళ్ళు ఏమంటారంటే, లేదు యాక్చువల్గా మాకేం ఎఫెక్ట్ కనిపించలేదు అంటారు. దట్ ఈస్ పాసిబుల్. ఎందుకు? ఈ పర్టికులర్ శాంపుల్ వీలో రియల్ ఇంటెలిజెంట్ ఉండొచ్చు. ఇంటెలిజెంట్ వాళ్ళు ట్యూషన్ ఉన్నా చదువుతారు, లేకున్నా చదువుతారు, స్కూల్ అయినా చదువుతారు, బయట ఎట్లయినా చదువుతారు వాళ్ళు. ఓకే, ఈ మిగిలిన 60 మెంబర్స్ దద్దమ్మలు ఉండొచ్చు. Okay, just as an example. Okay, or they might be weak learners. Fine. So in that scenario, when you combine the whole population, school is looking at the whole population as a whole and is saying, hey, it did not affect actually. Okay, so in that scenario, what we have done, we have rejected a true null hypothesis. Okay, in the overall picture now it is true. Okay, when you are assuming, see, there are 2 points. When you are creating a statement, we don't know which one is true, which one is false. These are just hypotheses based on our testing. You are saying, based upon my testing, I'm saying I'm not just giving a statement, this is true, that is true. That is not my job, because I don't have the overall population data. Okay, but I am creating a hypothesis and I'm creating some statistic, and I'm saying, based upon this evidence, this confidence interval, this and that, I am rejecting, I'm accepting. That is my only statement. Okay, but if someone gives me the overall picture and says, hey, actually your null hypothesis is false, man, you have rejected but you are accepted, or it is true, man, but you have rejected, so then that is an error. So is that clear, everybody?
Yes.
Yes, sir.
Okay, perfect. Good, guys. I'm happy that you guys asked doubts and clarified. See, because that is a magic. So once you do that, right, so you will remember this concept for long time. Okay, so because you are thinking, you are putting some thoughts, right, so then you will analyze, then you will contradict, then you will understand, so then obviously it will stay in your mind. Okay, so even if you forget also, again you can just quickly recall. Okay, and because you can just create these statements and in your mind, and you can, because we already had a discussion, so you can say, hey, we are just assuming, but based upon the overall picture we can be false. Okay, so that's a fundamental point. So now coming over here, coming here. So there are two types of errors as we have seen. Okay, so let me take some nice pen. Yeah. So see, actually null hypothesis is true. This scenario, this is actual null hypothesis false. This scenario. Okay. Now, if the actual true null hypothesis you are rejecting, that is an error. Okay, but before that, we will see the happy cases. What is happy case? Null hypothesis is true and our decision is not to reject. That means accept. Okay, not rejecting means accept, right? Okay, so null hypothesis is true and we are not rejecting. So correct decision. Agree? And null hypothesis is false, and if it is false, we should reject, and we are rejecting. Okay, so this is also correct decision. Agree?
Yes, Santosh.
Perfect. But as we just discussed, if null hypothesis is true, instead of accepting, if you reject, that is an error. Okay. Similarly, if null hypothesis is false, you should reject, but you do not reject. That is also error. Okay. So there are two types of errors. So now type 1 error is when you reject a true null hypothesis. Okay. So type 1 error is when you reject a true null hypothesis. Type 2 error is when you accept a false null hypothesis. Okay. So it might be slightly confusing, but pay attention, guys. Okay. So for this, we will see an example actually. Okay. See. Okay, fine. See, type 1 is when you reject a true null hypothesis. Type 2 is when you accept a false null hypothesis. Okay. And type 1 is also called as significance level or size of critical region. Okay. The probability, see, the probability of committing type 1 error is equal to significance level or size of critical region. Okay. It's rejecting a true null hypothesis. See, in this scenario also, what was the alpha, guys? The alpha region, what we are saying 5%, 1%, what did we put it here? It is a probability of rejecting null hypothesis when it is actually true. Yes. Same thing here, right? Here also, when you reject a true null hypothesis, that means null hypothesis is true, but you are rejecting. Same thing. When it is actually true, you are rejecting. That is alpha. That is your significance level. All this time, when you are considering this area, okay, this 5 alpha by 2, and in every example, okay, that alpha what you are considering, right, this 5%, that is what? That is just type 1 error, which is the probability of rejecting null hypothesis when it is true, or you can simply say the probability of rejecting a true null hypothesis. Is it clear?
Yes, sir.
No?
Clear, sir.
Yes, okay. And another scenario is when you accept a false null hypothesis. Okay, that means it is actually false, but you are accepting. That is type 2 error. Okay. So here you are seeing two words, false positive, false negative. Okay. So these two I will not discuss now because there is a complete separate topic regarding this. And this, whatever you are seeing these two, right? These are the fundamental concepts, I would say, for calculating any model's performance. Okay, these are related to the models, machine learning models, performance metrics. We call it as metrics. Okay, so there we are going to see it in detail. Okay, so whatever you do, right? So ultimately, you are going to calculate how better the model is, or how worse the model is performing based upon these values. We have like true positive, true negative, false positive, false negative. Okay, so these are the extremely important concepts, right? So without this, you cannot understand what is how model is performing. Okay, so there we are going to see it in detail. Okay, now if you start, you will get confused. Okay, so but just as of now, just understand that this is type 1 error and this is type 2 error. Okay, so type 1 is simply rejecting the true null hypothesis, which is also called as alpha or significance. Okay, or size of critical region. Okay, that's why there are so many names, right? So sometimes it might be like a bit confusing. Okay, but for the first time, okay, but later you will understand. So type 1 error is nothing but rejecting a true null hypothesis, which is also called as false positive, which is also equal to significance level, or which is also equal to the critical region, alpha. So simply alpha is rejecting null hypothesis when it is true. Cool. Now coming to type 2 error, which is false negative. Okay, forget about false negative. Type 2 is a probability of committing type 2. Okay, the probability of committing type 2 is equal to the beta B, and is called the power of test. Okay, B is not rejecting null hypothesis when it is true. Okay, that means what? Type 2 error is accepting a false null hypothesis. Okay, accepting a false null hypothesis, or in other words, when it is true, you're not rejecting, or when it is false, we're accepting. Okay, we'll stick to this. Again, you might get confused. Okay, so accepting a false null hypothesis. Okay, so in these two scenarios, now my important question is, which one you think is more dangerous? I will again ask. See, one is the null hypothesis is true, but you rejected. Second is null hypothesis is false, but you accepted. Which one is more dangerous? We'll try to understand. See, there is this door. Okay, this is your house. Okay, this is your house. Okay, let's say you are inside. Okay, you have your TV, everything. Okay, this is your house. Now, okay, this is you. And let's say you are having your brother. Okay, your bro. Okay, now you are watching a movie inside. Okay, this is your house. Now there is a stranger. Okay, now false null for type 1 error is rejecting a true null hypothesis. That means what? Whatever you know, you are rejecting it. That means whomever you know, you are sending that guy out. Okay, so type 1 is rejecting true null hypothesis. That means this guy is true, but you are rejecting. That means this your own friend you are sending out. That means you are sending your brother out. Okay, type 1 is this guys will go out. Okay, type 1 is bro out. Okay, getting guys? Type 2 is when you're accepting a false null hypothesis. Okay, that means what? Accepting false. That means you are accepting some stranger you don't know. Okay, so you don't know this guy, but you're accepting a stranger inside your house. Okay, type 2 is stranger in. Okay, see, type 1 is rejecting a true null hypothesis. That means true, whatever you know, you are rejecting that person. Okay, that means your brother you are sending out. Type 1. Type 2 is you are accepting a false null hypothesis. That means you don't know this guy, but you are accepting inside the house. Type 2. That is stranger inside. Now tell me, which one you think is more dangerous in type 1 and type 2?
Type 2.
Okay, everyone?
Yes, sir. Type
More dangerous is type 2, but yeah.
Why?
I mean, we don't know someone and we are simply accepting whatever it is. Stranger, right?
But Sirisha, you're not answering. You will accept stranger or you will send your brother outside?
No, sir. I think both.
Both are equally dangerous.
Both are dangerous.
Yeah, but which one is more dangerous? I'm asking.
Bro out. Type 1.
Type 1. So you are saying accepting a stranger inside is less danger than sending your brother outside? Why?
Yes.
Your brother is More dangerous than the stranger? No, I'm not. It's not about your specific brother, general brother. See, you don't know that stranger. You don't know what that guy is, who that guy is, what he's up to, what he can do. You're accepting that person inside your house. Okay. In other scenario, you know your brother. You're just sending him outside. Which one is more dangerous?
Type 2 only, sir.
Yes. So it's actually type 2. Okay. So as you said, type 2 error is a more dangerous. So that's why it's called the probability of committing type 2 error. Okay. The probability of committing type 2 error is called the power of the test. Okay. The power of the test. Okay. The probability of committing this error. So if this error is less, that means our testing is better. Okay. That means our whatever we are taking decisions that are more perfect. So, and that's why it's called false negative. Okay. So I'm just telling you because we came across this. So in most of the models, right? So we want the model should have less false negatives. Okay. Less false negatives. If the model is giving less false negatives, that means the model is more strong. Okay. But we'll see in the machine learning scenario. But as of now, sorry. The probability of committing type 2 error is also called the power of test, because committing type 2 error is much danger than the type 1 error. Okay. Cool. So now, are you guys going to college?
Yes, sir.
Oh, okay. Fine. In that case, I would say those will be today's topic. And actually, there is next important, one of the most important topic is p-value, guys. P-value is so important. I would say it's one of the favorite question for every interviewer. And if at all is asking you something in the statistics, definitely you can expect it's from the p-value, because whole statistic they will forget and they will only ask p-value. Even if you search internet also, the famous machine learning statistical questions, definitely there will be in the top one or two, it will be p-value. They'll simply ask what is p-value and they will ask some questions around it. Okay, so this is the most important thing I would say in the whole statistics. Okay, so that will be our next topic. Okay, so I would say tomorrow. So you can join tomorrow, right?
Yeah, Santosh.
Yes, sir.
Okay, so tomorrow we are going to discuss p-value and we are going to understand the example of p-value with some examples. Okay, and with that, I would say we have covered almost most of the topics, and what will be left of left out topics would be few tests, guys. Okay, some like t-test. Okay, the list of topics will be just few t-test, and it's called chi-square test, and something it's called ANOVA. Okay, it's called ANOVA, right? So there are just 3 tests left. So I think this will take one class, probably p-value will take one class, and this might take just 2 more classes. So overall there might be just 3 classes. Okay, so today's first, right? Tomorrow will be 1 class, and okay, I don't want to take on Sunday. Yeah, so mostly on 4th or 5th we'll try to wrap up the stats module. Okay, and then we are going to start next important concept called as NumPy. Okay, and just the goal is NumPy and pandas and matplotlib. Okay, okay, fine. So that would be from my end, I would say. So tomorrow we'll discuss the p-value. Okay, fine. Are we good, guys? Do you understand the concepts?
Yes, sir.
Yes, Santosh.
Okay, fine. Yeah, so in just in case, can we take today, if possible, today or tomorrow in the evening time, can we take one more class? so that we can wrap the statistics in this week and freshly we can start. That's my idea, but it totally depends on you guys. If you are fine, we can do that.
Okay, sir. For me, okay.
Okay, Santosh.
Okay, sure.
Okay.
Sir, take today only, sir, if you want to take.
Oh, okay. Tomorrow? What, tomorrow? Because Saturday, right? So I have a weekend on Saturday. I think if we take today evening one class and tomorrow morning, tomorrow evening, so we'll have 1, 2, 3 classes. That should be enough. What say, guys?
Yeah, okay, Santosh. For me.
Sirisha is giving scary face. Okay.
Okay, sir.
What about you, Meghana?
Okay, sir, it's fine.
Yeah, we'll see. Mostly we'll take today or tomorrow, but if I think we'll take both. Okay, don't worry, Srisha. We'll see. Okay, fine, guys. Thank you so much for joining. We'll meet tomorrow or today evening. We'll discuss in the group.
Sure.
Okay, bye.
Okay, sir. Thank you.
Thanks.